Hello, good day everyone. So today I'll be going to discuss about the mechanical overload or underload protection of a three-phase induction motor. In machine operation, a sudden change in the mechanical load can be used to detect a broken tool or free device and stop the machine. Mixing operation, changes in the mechanical load can be used to detect significant changes in viscosity and initiate a corrective action or warn supervising personnel. Also, in application where a motor drives a mechanical load through a belt, a sudden decrease of the mechanical load can be used to detect a broken belt and stop the motor. Fortunately, induction motors are electrical devices which operate with active power and also a reactive power. The amounts of active power and reactive power in induction motor vary considerably as the mechanical load applied to the motor. The motor power factor varies greatly as the mechanical load varies. So next, I'll be going to show to you the circuit diagram of the mechanical overload protection implemented with a power factor relay applied to a three-phase induction motor. So the following component that we are going to use in this circuit is that need to use the voltage transformer, current transformer, protective relay, induction motor, and also a power supply. So what is voltage transformer? Voltage transformer is also called a potential transformer or PT. It is parallel connected type of instrument transformer. They are designed to present a negligible load to the supply being measured and have an accurate voltage ratio and phase relationship to enable accurate secondary connected metering. The other hand, current transformer or CT is used to measure the current of another circuit. So CTs are used worldwide to monitor high voltage lines across national power grids. A CT is designed to produce an alternating current in its secondary winding that is proportional to the current that it is measuring in its primary. Next is an induction motor or asynchronous motor. It's an, A- it's an AC electric motor in which the electric current in the rotor needed to produce torque is obtained by electromagnetic induction from the magnetic field of the stator winding. On the other hand, motor power factor relay is a protective relay that is sensitive to power factor because the phase angle between the motor current and voltage and thus the power factor is dependent on the mechanical load applied to the motor. This relay can be used to detect either underload or overload conditions for a three-phase induction motor. So the last one or the most commonly used, most important component in a circuit is a power supply. What is power supply? So a power supply is enclosed in a full-size EMS module. It can be used to protect it can be used to power most of the EMS module of the electricity and new energy training equipment. This power supply provides DC power and AC power both fixed and variable, single phase and three phase. So next is the connection diagram of the equipment in the EMS workstation. So the following component that we are going to use is the transmission grid A, squirrel cage induction motor, prime mover or dynamometer, and also we need to use the watt meter or the var meter, and so on. So let us discuss what are the following components. So first is the watt meter or the var meter module. So it is fitted with one watt meter and one var meter and is designed to indicate direct measurement of active and reactive power in balanced three-phase circuits. Each meter has a zero center cable scale to show the direction of power flow. Its electronic design uses voltage and current sensors to sample line voltage and current. Voltage and current circuits are internally connected so that students only have to connect the line and load terminals of the module. The next component is the AC voltmeter module. It is fitted with three separate multi-range AC voltmeters for simultaneous measurement of three-phase voltage. Meter ranges and scalar values of each instrument have been carefully selected for compatibility and are appropriate for the electrical values to be measured. All meter readings are direct indication and do not require the indicated value to be mentally multiplied by a constant. The next is the transmission grid A. This consists of transmission grid installed in a full-height EMS module. This module is used to open and close an AC power circuit under normal conditions or to interrupt this circuit under fault or abnormal situations. It can also be used for the connection of EMS motor or generator sets and loads as well as the protective relaying equipment for transmission grid protection. The next circuit that I'll be going to show to you is the connection diagram of the equipment in the protective relaying control station. So here we are going to use a motor power factor relay, control relays 2, control relay 1, a DC power supply, and so on. So what is control relay 2? So model 3808 and the control relays 1 model 3807 includes all necessary control relay to perform the exercise in the protective relaying training system model 8007 without the need for the protective relaying control station model 3806. The control relay 2 comprises two adjustable DC time delay relays. The module must be installed on a single rail workstation, model 3105-A or anything equivalent. Next is the control relay or the control relay 1. It's a general purpose industrial type relay with two sets of normally open contacts and two sets of normally closed contacts. Next is the interconnection module. It consists of three sets of 12 4mm safety banana jacks and three multiple contact connectors mounted in the front panel of a full-height EMS module. Three interconnection cables supplied with the modules are used to connect the banana jacks on the interconnection module to the banana jacks on the interconnection panel of the protective relaying control station. So this is the circuit that I have made in the protective relaying control station. Hello, good evening. So for the continuation, I will show to you the connection of the protective relaying control station. So as you can see, this module is the interconnection module. This one is our motor power factor relay. This one is our control relay 2. This one is the control relay 1 or the control relay. And this one is our DC power supply. Okay, so for the connection, A1 is connected to our line 1. This one. Our A2 is connected to our line 2. Our A3 is connected to our line 3. And our A4, this wire is connected to our number 11 of the motor power factor relay. Okay, next is on to down part of our diagram. So the B4, which is here, the yellow wire or the yellow line, So it is connected with the normally closed for motor power factor relay. So our neutral line of the motor power factor relay is connected this one. It is connected with the normally open of the control relay 1. So our control relay 1 or the normally open output of the control relay 1 is connected to the normally closed. And our normally closed here is connected with this line. Is connected with the I think V1. Okay, so the V1. So let's go back to the normally open. So we will connect the normally open here, the normally closed contact. So the output of normally closed is connected to the coil, the coil of the CR1. So another coil or the A2 is connected to the coil of the control relay 2, which is here. And our one coil is connected to our DC power supply, so the one. And our 4 DC power supply is connected with V3. And our V5 here, 5 is connected to our normally open of our controller 2. And the normally open here is connected in the normally open and the normally closed of the control relay 1. Also in our V6, it is connected with coil of the control relay 2. So that's the connection of the active relay and control station.